Hey, welcome everyone. I think we're recording now. Thanks for coming very much. I'm very happy to give a very brief introduction to Laura Callis. Laura teaches math and statistics at Curry College near Boston, and she'll be talking to us today about a playful activity that she uses with her students. So take it away, Laura, please.
Awesome, thanks. So I'm gonna share my screen. Give it a second so everyone can see. And I'm gonna make you big on the other screen so I can see your faces. Okay. So my name is Laura Callis. I've been teaching at Curry College for 9 years now. I was a high school teacher before I got my doctorate, and I teach mostly statistics and math for teachers. But sometimes I'll teach like a history of math class or some other random elective too. And this is an activity we've done with our classes in a bunch of different classes about paper airplanes. And the reason that we do this is, well, for a few different reasons. One, I love paper airplanes. I have he just turned, he'll be turning 10 in February, a 10-year-old boy, and whenever we get junk mail, we turn it into paper airplanes, and it's just a fun activity. So I think that they're fun and joyful. But also, I think this lesson helps us think about multivariable thinking. Even if you haven't done, linear regression or anything like that yet, you can still engage in multivariable thinking by thinking about paper airplanes. Right from day one. And then the new Universal Design for Learning framework, which is recommendations for working with diverse learners, including neurodivergent learners, recommends nurturing joy and play. So this is a way to integrate play, but you're still, learning mathematics. So that's why I like this lesson. So, where this could fall in the curriculum, today we're going to be thinking about study design and descriptive statistics and data displays. So, even if you haven't gotten to inferential statistics, you can do some of the things that we're talking about here. But then, if you do want to do inferential statistics, you could do that as well. You could extend. So, that's what we're talking about. So we're going to go through the statistical investigation process, which is something that we really emphasize in our courses so that students realize that there's a process to figuring out things about the world. Mostly we're going to focus on those first 3 steps, asking a research question and designing a study and collecting data and exploring the data, but you could easily move into making inferences and drawing conclusions as well. So our research question, the first step, is which is the best paper airplane model? But in order to answer that, we have to make that question measurable. We have to talk about, well, what do we mean by best? So let's type in the chat, what do you think we mean when we say it's the best paper airplane model? What does it do? And I'm going to count down to give everybody a time to think and type. When I count down to 1, hit enter. What do you think we mean by best? And 3, 2, 1. Go ahead and type in the chat. Ooh, so many good ideas. Nice. So some people say fly the highest, some people say fly the longest, some people say fly straight. That's a good one. Longest time of flight, so it spends the most time in the air even if it doesn't go very far, maybe. A straight line. Awesome. These are all different variables. These are all different ways that we could define our outcome variable. And some kids will even say, or students will say, oh, it does cool tricks, so like does a loop-de-loop or something. So that would be like a qualitative maybe outcome variable. I agree that those are all interesting variables that we could study. Today we're going to be looking at which paper airplane flies the furthest, the length of the distance. But we could do other investigations too. So in order to design our study, the second step in the process, we have to think about what kinds of things influence how far a paper airplane go. So we're going to do another waterfall. What do you think? What can influence how far a paper airplane goes? And don't hit enter yet. I'm going to give everybody some time to type. Might be a longer one because you might have lots of ideas. Okay, so I'm going to count down, and when I say 1, go ahead and hit enter. What kind of things influence how far a paper airplane can go? 3, 2, 1. Hit enter. Ooh, Cool. So we've got paper density and the size of the paper. The type of paper it's made of, if you're using like oak tag or if you're using tracing paper or newspaper, those might be all different. The shape, the weight, how it's thrown, the drag on the wings, the skill of the thrower, the design. Yeah, these are all really good ideas. And you can see that some of these ideas are part of the design, right? If we're thinking about how wide the wings are, that's going to influence how far the plane can go. But that's part of the design. That's one of the things we're thinking about investigating. One of the things we want to know. But then there's other things that we don't really, that's not what we're testing. Like the thickness of the paper or the type of paper it's made of, the angle that it's being thrown at, how strong the person is who's throwing it or how skilled the person is. Those are different variables. They don't have to do with the design of the paper airplane. So if we were adding some language onto that, we might say that those are confounding variables, right? So there could also be wind if we're doing this outside. It could be the angle of the throw that I saw on there. This person is throwing it straight up. That might be different from throwing it straight forward. How hard it's thrown, if it's folded well. This paper airplane is not folded well, right? How well it's folded is going to matter too, the type of material. And so in order to be sure that it's the type of airplane, the model that is impacting the distance, we would really ideally like everything to be the same. If we're going to compare, say, 3 different types of paper airplane designs, then we would want all of the flights in each of those 3 groups to have the same type of material, to have the same kind of skill level of the person that's throwing it. We'd want them to be the same so that we know the only variable that's different is the design of the paper airplane. So that's the thing that's making it go farther. So when we talked with students, we came up with some ideas for how to address some of these potential confounding variables. Because the weather could impact it, we were going to do it indoors. To control for the material, we're going to use all the same type of material on all of the paper airplanes. For individual skills, some people are good at throwing paper airplanes, some people are not. What we're going to do is we want those different groups of the types of airplanes to all be the same. So what we're going to do is each person is going to throw each type of airplane. That way we can see that, well, the overall skill level in each group is kind of the same, right? We came up with this idea that the force of the launch, some people were throwing it really hard and some people were throwing it lightly. That could impact how far it goes. And so we got these little launchers right here that you can buy online. I think they were like $10 or so. And they have a clothespin that holds a rubber band, and you slide the paper airplane into it and then you let it go so that they're all kind of getting the same amount of force. And then because we were concerned about the angle of the launch, we attached these paper clinometers. They're like a protractor. And a string with a weight on it, and usually we use them for like looking up in the sky to see how high a star is or something like that, but we use those to see, was the angle of our launch going to be at 0 degrees, and let's make sure that everybody has the same angle. But the thing of it is that as we're trying to control for all of these different potential variables, we might be impacting how we could generalize our results to their settings, right? Like, how often are you going to have a launcher when you're throwing a paper airplane, right? So maybe we find out the best paper airplane when we use a launcher, but that might not be what we want to know about. Maybe we don't want to know only when it's 0 degrees. You know, all these things can kind of influence how far we can generalize our results. So we're going to play with some data. This particular data set, pre-service teachers flew the airplanes without the launchers, and then we had a discussion and they realized that that could be a problem, right? People were throwing it so different. So when we had some 5th graders visit campus, the 5th graders flew the paper airplanes with the launchers. And each type of paper airplane, there's 3 different types. One's the Acrobat, one's the Ranger, and one's the Classic. They're all on different colored paper so that we could keep them straight. Everybody folded their own airplane, so that's kind of enmeshed in the skill level, right? Not everybody's as good at folding paper airplanes. And then we entered it on a Google form. Some of them were written on hand pieces of paper, so we had to enter them on Google Forms. And then we had to clean it up because sometimes students would write, inches, the word inches, and then the computer wouldn't be able to see it as a number. So we did a little data cleaning. So I'm going to put this link in the chat, and we're going to break up into groups just for a few minutes to sort of play with the data. So let me just label this so you know what it is. This is the data. Oops. In CODAP. And I'll show you how to use CodeUp, and you can also use the QR code if that's easier for you. So let me pull that up just to show you how to use it. Oops, email. So in CodeApp, if you were doing this in your class, you could go to File, Open, and it will ask you if you want to open from your most recently copied data. But we've got the data loaded in here already, and you can do this for your students too. You could load it into CodeApp and just send them a link. And you would click Graph in order to get this graph over here. And what's really nice is you don't have to, like an SPSS or something, right? You have to know like which menu to click on and which type of graph you want. And this is really good for quick and dirty data analysis because you just drag the title over. So where it says model, I'm going to click and hold, and I'm just dragging it over to the graph, and it'll decide on a graph for me. And then if I click distance, I can drag it to different places. And if I dragged it to the middle, it kind of color-coded by distance. That's not really what I want. So I can always start over, or I can even drag the variable and put it in different places. So now I've got a line plot over here. And it allows you to sort of play and try a bunch of different types of data displays without having to like go through menu commands or having to learn anything about coding or things like that. So what I'm interested in is the distance. And I'm interested in how that distance differs by the type of paper airplane. So I'm going to drag it over to the side so that I get 3 different dot plots. And the benefit of having students actually fly the planes and enter in the data is that they understand what each of these dots means. So if that's important to you, then you might want to think about that. But if you've been working with data for a while, maybe it doesn't matter if people insert their own data. So this particular dot was when Kelsey flew the blue classic plane, and that's how far she went. You can add different features too. So if you click on that ruler, you can add a bar that shows the mean. You can have them estimate the mean, or you can click show measure labels and it will calculate the mean for you. You can do the same thing with the median, and then the box plot is kind of nice too. There's also measures of spread, the standard deviation, and mean absolute deviation that you can have it calculate too. So you don't have to sit there and do a bunch of computations or remember what command to put in order to report out the standard deviation. So I am going to, you can also just drop with a CSV file too into CodeUp. So I hope everybody has that link, and I'd like us to maybe go to groups for maybe 5 to 7 minutes just to play with the data and talk about what you see or what you don't see or what you wish you could be able to see.
How many breakout rooms would you like?
How many folks do we have?
24.
So maybe 4?
Okay. Think I've opened breakout rooms, so go ahead to your room.
Hi, welcome back. Do we have everyone? Oh, people are still rolling in. Welcome back. So I hope folks got a chance to play. Are there questions or things that you'd like to see, or things that you noticed, or?
Is there a way to change the box colors, the legend box colors?
Oh, like that's a good question. I am not sure.
Yes, there is the paintbrush.
Oh, yeah. Oh,
Um,
thank you.
but I don't know if it can be different for different categories.
It can. I just tried it. Thank you. Yeah.
Oh, cool. So you can. So I'll show folks so that. Click off. Unless you want to show us. Do you want to show us? Here, I'll show. So,
oh, sorry. Were you talking to me?
Yeah, because I didn't know it.
Sorry. So I'll show. So you can see my CodeUp screen. Is that right?
Yes.
Yes.
Yeah. Okay. So I'm going to pull up a graph, and let's say that we're looking at distance, but instead of making, oops, I'm highlighting some, so it's highlighting some. So notice if you have them highlighted, it's showing you the corresponding dot. So let's say that we were interested in, I clicked it wrong, distance, and having a color-coded graph. So instead of putting the launcher on the side, I'm going to put it in the middle. And maybe for our students, so like my husband is slightly colorblind, so he wouldn't be able to distinguish between these two colors that easily. Maybe we want to change it to something more dramatic. We can click on the paintbrush, and then we can change it to something that's more like he's better with like blues against reds than oranges and red, like that. And then another thing you can do, there was a question about filtering too, which I should have reminded myself how to filter before, but you can filter if you wanted to say only look at, sorry, it's a little slow when I'm clicking. If you wanted to say only look at all the launchers, you could highlight all of the ones that have the launcher, pretend I'm highlighting them all, and then click on the eyeball, and you can set aside the cases or set aside the unselected cases and then make a graph would be one way that you could do that. There might be other ways too, though. I don't know if anybody has another way if you just wanted to look at a subset separate.
Yeah, you can do it with the graph, the easiest way actually. So what I do with my students, if you graph it and you highlight the ones that you want to put aside, then you go back to the case table, you click on the eye, and you say put aside selected cases. And then everything disappears with the case table. It works better if it is not like yours in order. Yeah, if they're scattered all everywhere in the case table, then graphs would be more preferable and faster to do it.
So
and of course, there is a programming if command you can do it too in the table, in the case table. But with students, the easiest way is with the graph.
Okay, so if you already have the graph, you can just select them all.
Yeah, for example, do the same thing. You will just put whatever you want to put. Put it on the horizontal. You put it on the horizontal axis. Usually I do horizontal.
Oops, I keep. It's like a little bit slower because of, and then I let go at the wrong time.
Yeah, so put it on the horizontal axis. Okay, now. Yes, good. Now highlight everything that you want to put aside. Yes. Then go to the eye, but not here, not on the graph. Go to the case table. Go to the eye that is on the case table. Click it in the right corner of the case table. Good. Click on this eye. And click on set aside selected cases or unselected. Somehow it is not, yeah. And it disappeared.
Yeah,
and you can do it for all of them and keep only one category if you will use the shift key.
Yeah. That is a little bit nicer than having to.
Yeah, it's just faster, it's just easiest for students from my experience. Yeah.
Yeah. And then we've got a comment in the chat too. Can also filter on the graph. Oh, so many. You're saying the same thing. Yeah. Cool. Oops. Oh no. I didn't mean to get rid of it. It's okay. I have the link. Great. So let me pull up. Are there other tricks or interesting things that people wanted to share? Or what you noticed? So let me share my screen for some other things that we can do. Okay, there it goes. So you can kind of start having these conversations about making conclusions. We would still probably want to talk about inference, but I think the nice thing about the airplane data is you can see the spread so widely compared to the mean. So a lot of times coming from elementary and middle school, students are just so used to just find the mean, compare the mean, that's the answer, right? But when you see this data and you see that, well, yeah, the means are different from each other, but the spread is so big that we kind of have to figure out, well, is that a really, meaningful difference? After all, there's not that many paper airplanes. Maybe we just happen to get, a few paper airplanes that are a little bit a couple of really lucky throws or something like that, right? So it kind of helps you to start focusing on variation and not just focus on the mean, or the median is the answer. And then I think also being able to understand what a box plot means, it helps a lot too, because you can see the individual airplanes by looking at the dots and see that, oh, there's about 25% of the airplanes are above this level, which can be kind of hard when you're looking at just the box plot all by itself. So I know that we probably would have questions. The question I always get when I share this activity is, well, geez, how do you manage this in class, right? Like the class time is the thing that we have so much pressure with. But I've actually done this in 10 minutes before. So it kind of depends on like how much time you have, but how important is it that students connect the actions to their graph. So sometimes when you're first doing a box and whisker plot and students don't really know what they're looking at, or even if you're just doing a dot plot to start, you really need them to understand that one row of one plane is one dot, right, in order to interpret the data. But at other times you've been doing data analysis for so long that they kind of already know what the unit of analysis is going to be. So that kind of depends. You need them to actually physically do the action and connect it to the graph. I've pre-folded the paper airplanes before during faculty meeting and brought them with me. That way, first of all, I know that they're folded pretty well, but it also saves that time from having the students fold the paper airplane. And I've found that actually students aren't that great at folding paper airplanes. You really have to go step by step. Okay, now I'm folding corner 1 down to corner 3, even when using the printout of the patterns and the videos. So you have to kind of make that decision. On the other hand, if you really want students to think about, well, why would the blue plane maybe fly the furthest, being able to physically touch the materials and build it themselves helps them to come up with some hypotheses. Like, oh, this one feels a little bit heavier in the front. I wonder, because we rolled it up, I wonder if that's why it's going to be flying further. Another thing is thinking about how are you going to directly measure. So you might have, meter sticks, or you might have tape measures, but there's also a measure app on students' iPhones that they can use, and that might be good for those like diagonal distances. Whereas like the tape measure, you have to roll it out each and every time, which might take more time. When we had a big group do it, we had tape measures rolled out all across the floor, and then students were just measuring like one direction of the distance, so they weren't measuring the full distance that it had thrown. They were just measuring how far out from like the starting point, kind of. So just in one kind of direction. So if it was flying diagonal, they were underestimating how far the flight was. But I've also just had them, instead of directly measure, I have the data already, and if I think that they'll understand where the data comes from, I've just given them the paper airplanes and had them throw it in class and just talk qualitatively, like for you in that flight, which ones seem to fly the farthest. And that way they get a sense of what it is they're looking at, and they have a little bit of fun with paper airplanes. It kind of, coming into a mathematics class, a lot of students might be scared, and you're showing them that actually this is kind of fun and a little bit lighter than there's no reason to be scared. We can have fun here too. So those are different things that you might want to think about when you're actually collecting the data. Is how close do you need students to be to the actual collection? Do you want them to be thinking about measurement error, like, oh, what do I do if it's halfway between, I don't know, a quarter of an inch and the next eighth of an inch? Or do you want them to, you're not really focusing on that for that lesson? And then how to collect the data all in one place. So I used a Google form. So students were just entering in the data on their phones or on their computers, but they would make mistakes, like they would write in the word inches, and so I had to go back through and clean that up. Some of them had 2-word names, or they put in their partner's name too, and so I had to squish those names together because the computer might read the space as, oh, a new variable is starting. So we just did some tidying. We made the variable names just one word, because then it wouldn't try to make a new column. But you can also just use the existing data and have them insert the case as a new line on CodeApp, and that way they're still represented in the data, so they can sort of understand what it is they're looking at, but you don't have to worry about cleaning all the data ahead of time. And then Desmos and Amplify also work. So Desmos is now Amplify, and so I just wanted to kind of show you what that looks like. So we use it a lot at Curry because we can hold students accountable for actually doing things. All right, let me just turn this off so I can see you. Okay, I can see you now. So what Amplify is, and I'll put the link in the chat if you want to take a look at the student side. This is not what the one that I actually use. This is just so that you can kind of see what the questions look like. So what students see, and you don't have to log in if you don't want to. It just saves your answers if you log in. So what students see are questions like this. So they might have like an open response. They might have a multiple choice. You can have multiple select. There's ranking questions. There's matching card questions. And there are some collect data slides. So maybe if the student thinks that the classic blue flew the furthest, and then they click share with class, they can see the entire class's data here. And the same thing with the box and whisker plot. They could put in the actual distance that the plane flew, and then they can see everybody else's data too, and they start to see a box plot. So that could be another way that you're looking at students' data. But the bigger classes, it's nice because as a teacher, I can click, if I have several different things I want students to be doing, I can click summary and see where students are. Like I might say, Erin, can you join us over on slide 4 to keep the pace a little bit easier. And you can mark the questions. I mean, this is not a yes or no question, like a correct or not correct question, because it's about opinion, but you can have questions that have right answers and wrong answers, and you can click on that slide and quickly see like who's having issues so that you can go meet with those students individually. Or you might say, hey, Regina, can you explain why you think this, because you know that she's got the right answer. So that's another way that you can collect data, but also maybe build in some space for students to think and for you to be able to see their thinking too. All right. And then, oh, sorry, it's not clicking. There we go. There's like a little delay. So there's videos that will show you how to fold the paper airplanes. If you think students will need, I'm going to put it in the chat too. Fold airplanes. If you think students will need some guidance. And then when I chose those particular patterns, there's a bunch of patterns here that might actually give you more of a difference between the flight distances. I happened to pick the patterns that I thought were the easiest to fold because I wasn't sure that they would be good at folding patterns. But that might not be your criteria. Maybe you really do want to see a bigger difference between those means and medians because you want to do a statistical test that looks at the difference between means and medians. So you might want to investigate some of those patterns as well. And just know that you're going to have to support students in folding them a little bit more closely.
Then copy and paste it in the Word document.
So are there any thoughts and questions or ideas about how you might bring play into the statistics classroom? Either this or other ideas?
I just did have a question. I don't see any way to do like a test of the difference of means in CODAP. I don't know if anybody else has experience with that.
Yeah, there are all tests in CODAP. It depends on the variables that you have in your case table. So you the option of difference of two means will appear if you will have something in your case table that allows for it.
Okay, so if I have like the distances of the different
Yeah,
types of airplanes.
so you have two types. Yeah, you have two categories and the distances, and then you drop into you go to Testimate. I do not have any case table. Let me try to see if I can find something very fast that what I use in my classes. Let me check. Such that I can demonstrate.
Well, the current one has launcher yes or no.
For the difference of two means, you have to have a quantitative variables. Do we have a quantitative variable? I do not have, I joined late. I do not have access to the previous data, whatever you're using.
Yeah.
Let me check what I have.
It went away. There it goes. So it should have the distance as a quantitative variable.
I put the CODAP link in the chat.
Let me look at it. You put in the chat something. I found actually my file if I can demonstrate.
Sure.
Yeah, can you
If you're
share?
able to share for that.
I can share mine. Okay. So let's see. Okay. So this is birth sample data, yeah? So you want to, let's see, you go to plugins, yeah, you go to statistical inferences, you go to Testimate. Okay.
Oh.
So then let's say that I want to compare, let's see what we have here. Birth weight, for example. Yeah, birth weight is numerical also. You drop here birth weight, and then you have another attribute. Let's say that I want to compare it with smoking, non-smoking mothers. Yeah, you drop the second variable here, correct? Then you have here mean of weight. You see the arrow. You click on the arrow, and then here differences of means, and here is ANOVA if you want. And you click and you see, and what is nice about it is that you see the hypothesis test. You can change anything here if it is not zero or something. You can change the confidence level if you want, and you can see how everything is changing. Yeah, the students can see and all this stuff. And if you click on this one, you can see, let's see, on this one, you will see all numbers that you need to see, standard deviation, standard error, and all this stuff.
Yeah.
Okay, yeah,
This
I
one is
thank
very
you
nice.
very
Yeah,
much. Yeah, I
yeah,
I
this
just
one is.
did it with the distance and model and came up with a p-value of 0.1377. So
Yeah,
there we go.
yeah. Mm-hmm. So something like this here.
We only get to comparing two means in our IntroStats course, so I've taken out the middle furthest plane, I forget which one it is, and done the simulation in the Rossman chance applets too.
Oh,
Yeah, CodeUp does very nice job with all randomization simulations, which is actually very cool. Yeah, this is very applicable. Yeah.
So I can pull up the Rossman chance applet and show you how we did that. And so it's this one here, comparing groups. And
You want to share your screen, Laura?
yeah, sorry. So I'm just going to use the default data to show it, but because I don't have the CodeApp data sorted to, it's really zoomed in. Well, it's zoomed in a lot. So I don't have the two airplane, just the two airplanes data. I have them all kind of mixed together. So I'm just going to use the existing data right here. So this is saying that you got a particular treatment, A, B, or C. We're going to use data, and it graphs it, and you can see show groups, and it's showing that, oh, this pinkish colored treatment seems to be doing a little better than, say, this orangey red colored treatment. And so if you click shuffle options, and I'm going to, because I don't know how far everybody has gone, I'm going to cut it down to just two options. So let's say we've got these, imagine there are more dots. We've got these two different groups. Some are given treatment B, some are given treatment A, and this is the strength that they are demonstrating. And so it seems like maybe treatment A might be leading to people getting more strength if this is an experiment. And so what this side of the applet does, if you're looking at doing simulation-based inference instead of just a straight-up test, is it shuffles those two groups. So it's saying like, okay, well, let's pretend that it's not really the treatment that led to the strength difference. It's just that the people who ended up having more strength were randomly assigned to the treatment A group. And so what difference would we expect to see if we did a bunch of shuffles like that? And so you can keep shuffling and develop your null distribution that way too. And so I can't copy and paste easily from CodeApp into here. I have to go back to another file. But what I do in my classes is we look at just two of the paper airplanes and we say like, okay, well, maybe it was just that the person who was flying it was a really good flyer, and it didn't really matter what paper airplane that they were flying. That paper airplane was going to fly that distance no matter what. And then we do a randomization to sort of see like, well, how often would that kind of happen if that were true? How often would we see that difference if that were true? I'm sorry, I don't have the data cleaned up to do the inference part, but that's kind of the idea. That might be another resource as well. Are there other things that folks do or questions that people have or other fun ways that you bring in play into your classes?
I use an idea from Beth Chance where you collect the student survey data and then they have to match the dot plots. But I make it into a competition where it's unnamed, but I make it into a competition that each table group is trying to match, and they have to label the title and the scale, and they get a point for like if they got the right variable, and they get a point for the scale. So it's like out of 12 points, and the group with the most points gets like a candy prize.
Oh, fun. Cool. So just even like changing the modality of like, let's do some matching together can kind of change it. Neat.
There was one activity that I heard of where you have people line up in order by height, and then you say, okay, we're going to make a histogram. And so then they have to bend themselves and figure out, how that works and, thinking about that process. And it's actually physical people moving. So it's, kinesthetic where they're actually doing it themselves. And you can do median, you can do, quartiles. So you can see what quartiles look like and so on.
Yeah. I like that because I think sometimes they see the area, the like horizontal area, they see it as the amount of units, and it's not the amount of units. All of these have the same amount of units in it. It's like the spread, right? For a box plot, and then for the histogram, they don't always understand that it's telling you how many in a category. That's really cool.
Something I did this semester, ours has started, sounds like none of yours has. Um, so it's I feel like it's very interactive and movement based, but it didn't really tie into a lot of what we did today, so that's why I asked. But in a class where they expect like to review the material I had put up, we did scatter plot movements this week, and so I put up like 8 or 9 different scatter plots around the room. They had to get in groups of groups 3, and I passed out playing cards, so they had to like find like all the twos were one group, all the aces were one group, so they didn't just like find their friends, or just like go where they were seated. And I had like a couple questions that I projected on the front of the board. Like day one, it was like, would this be a good linear plot? So it was a class that like they're expected to remember bivariate data, but so they answered a few like remind yourself about questions. And then so that was new to me this semester. And then also new, I said when the music starts, then you need to walk around the room and look at least 3 other scatter plots. And like groups had to write their answers on the whiteboards and like write what other groups wrote. And so they had like 5 to 7 minutes, like introduce your name, talk about the scatter plot, write your answers, and then a song's amount of time to walk around the room and look at other groups. And I did that on both days, and I feel like week one was in the books because that was I think they really liked it. So if you can bring like movement and song in, like that's something I'm experimenting with this semester.
That's really cool. Instead of like okay, 5 minutes we're going to spend, but to have like the length of a song be the amount of time they're going to spend, that's really cool. Yeah.
Last semester, I had them throwing a beach ball around. The beach ball was of the globe, and they had to tell me if their right index finger landed on water or land. And then we used to do the confidence interval for the proportion of the Earth that's water. And we also did it for hypothesis tests to see if we came up with 75%. And I had done it pre-COVID, but then I had to stop it during COVID, and I just did it again for the first time. And it was interesting because one class was very boring. They just passed it down the row and then to the back row and passed it down that row. That was my 8 a.m. class. My other classes were a little more enthusiastic about throwing it around. But I always wonder, though, when I do things like that, what an administrator would say if they passed my classroom and see this beach ball flying around the classroom. But the kids enjoyed it. It got them moving some, and it was a fun way to gather a minimum of 50 data points.
That's neat because it kind of gets at sampling, right? Like if they're just passing it, have we gotten rid of the randomness, right?
Yeah.
Yeah. And then you could compare. Always looking for activities where you know the population parameter because it's really hard. Like usually we don't, but you want them to understand. Yeah, that's how I might steal that.
I actually stole it from some high school AP teachers. So
Okay. There's my son loves Mark Rober. He's a YouTuber. He used to work for NASA, and he does like little engineering things like the glitter bomb and things like that. And he has one really good one about that talks about probability with arcade games. And so we've done to get them to think about like, okay, this is our theoretical probability. We take solo cups and do a kind of like beer pong type thing, red and blue ones. And so we think we should get, I don't know, there's 4 out of 5 cups are red, one's blue. We think we should get 4 out of 5. There's more than that. But what about, like, are we better than chance and things like that? Just to have a little bit of movement going on and distinguish, like, this is our theory, but this is the actual data that we're collecting, you know, because sometimes they get mixed up. And who can argue with beer pong? Cool. It was so fun hanging out with you. If you have other activities, share them on the Google group. I'm going to be hanging out here for a little while. If you want like to work one-on-one on CodeApp, I know it was new for some folks, and so if you want to like share screens and coach each other, we can do that too. But otherwise, good luck at the beginning of the semester, and let's stay friends. Send an email around if you have an idea on the Google group.
We do have another webinar next Friday at the same time. I'll be sending out a Zoom link probably Monday or something like that. Beth Chance and Lance Bryant will be presenting an activity about students measuring their body temperatures and asking what's a typical healthy human body temperature. Let me also put in the chat the link to where you can find all of these webinar descriptions and then materials and recordings. We'll post the recording from this webinar sometime over the next few days, in case you want to point a colleague who couldn't be here to it. Yeah, thanks for coming. Feel free to stick around and ask Laura questions more individually if you'd like. Thanks to Laura, of course.
This was great. Thank you. Good seeing everyone.
Good seeing you.
Thanks, Laura.
Yeah, thank you.